highlight the paths that represent B complement. Okay, so we want to represent B complement here. So what should we do? Well, any path that goes through a B complement should be highlighted, right? Except I don't see any B complements here. Okay, where are they? So here's where we have to use a bit of knowledge of our set operations, and not just the notation and blindly highlighting things relative to the notation. We have to remember, what does this mean? B complement is the set of things that are not in B. Okay? So another way of thinking of the paths that represent B complement, rather than just the ones that go through nodes that are called BC, we want to highlight any path that does not go through B. Okay? So we want to avoid anything passing along this branch going to the B. Okay? So we could go up to A, because that's not part of B, and then go to D, or we could go to A and then E. Okay? Those two paths are exactly what we're looking for. But C is also clearly not B. It's a separate, different branch. So we could go through C, then to D. So that's a path that is in not B. Or you go to C and then F. Okay? And the only thing that's left over are these blue paths that go through B. So they represent B. B intersect E and B intersect F. Okay? But we don't want those. So there we go. We've highlighted the paths that represent B complement. It's a good idea not only to be able to understand the symbols, but to be able to actually understand what they represent. So in this case, not. Because if I wanted something like A union D, I would want any path that goes through an A or a D. Okay? So it's not enough to just know the symbols. We want to be able to understand what they mean in case we see a slightly different looking trait.